When you analyze data, it's often important to see how two sets of value vary in relation to one another. For example, if people drive to get to your store, you might be interested in knowing if the distance they drive is related to how much they spend. In this movie, I will show you how to look at the relationship between two sets of values by calculating covariance. My sample file is 0502 single covariance, and you can find it in the Chapter 5 folder of the exercise files collection. I'll show you two different ways to calculate covariance. The first is the long way. So I will implement the formula that you see here in this graphic as part of the worksheet. And then, once you understand what's going on, I will show you how to use a built-in function to perform the same calculation. Rather than give an overview, I will go ahead and start implementing the formula that you see on the right in cell C2. So this will be for our first pair of values. So in C2, I will type an equal sign. And the first thing I want to do is subtract the average of the values in column 1 from the specific value in cell A2. So I'll type a left parentheses, A2, minus, and then we want to find the average or mean of the values in column 1, so that's average. And the range is A2 to A11. And I don't want that reference to change. I always want to refer to that set of values for the average. So I'll press F4, and I'll go back to A2, press F4 to make that an absolute reference. So I have my range of values, and I can type two right parentheses to close out that part of the calculation. Then I'll type an asterisk for multiplication, and we'll do the same thing for the values in column 2. So I'll go a little faster. We're going to multiply that by left parentheses B2 minus the average of the values in B2. And again, that will be an absolute reference, colon B11. And F4 again on the PC. On Mac, it's Command T. Then two right parentheses, and I will press Enter to create our calculation. And I have a covariance of 4.68. And it is a small value because we're working with small values in columns A and B. Now I want to copy this formula down so it covers every row of values going down to row 11 in the worksheet. So I will click cell C2, double click the fill handle at the bottom right corner. I know my mouse pointer is in the right place when it changes to a black cross. So I double clicked, and there I have covariances for each pair of values. Now I want to add all of that up. So I will click in cell C12, type an equal sign, and then I'll do sum. And that will be C2 to C11. And I want to divide that by the number of pairs. And I'll type in a / for division, 10, because that's the number I have, and enter. And I have an overall covariance of 0.48. So that is the mechanics of how the calculation is done. Now I'll show you how to do it with a built-in function. So I'll click in cell E3, type in equal sign, and the function that we'll use is covariance.p. Covariance.p returns the covariance of a population, and a population calculation assumes that you have every possible value, and you're working with them as part of the calculation. And then you need to enter in the two arrays of values. So I have A2 through A11, then a comma, and B2 through B11, then a right parentheses and enter. And you see that once again, we get the value of negative 0.48. So this value is very close to 0. And even though we're working with small numbers, that indicates that there probably isn't a very strong relationship between these two sets of values. I'll go back up to E3 and double click. And you might have noticed that when I was entering in the formula, we had two options for calculating covariance. Covariance P, which is what I demonstrated here, and covariance S. S assumes that you have a sample of your data. So I will highlight that, press Tab, and the function has been changed in the formula. I'll press Enter. And you can see that the value is slightly larger or at least farther away from 0 than the previous calculation. And that's because we are dividing by n minus 1 instead of just n. So it's a slightly more conservative way of doing the same calculation.